All right, first off, I am a high school teacher in Somerset High School in Somerset, Kentucky. This is, oh gosh, I've been doing this for a while, and I've been doing solar cars since 2018-19 was the first race, and been with two different schools, most recently Somerset High School, and have helped about 3 other schools get started in our state where we didn't have one program at all prior to that. What I'm going to talk to you now is, first off, are we up?
Working on it.
Okay. We're going to talk about mechanical drawings, the importance of them, wiring diagrams, and very briefly about schematics as well and their importance as well. And I'm going to give you a horror story regarding to that, was how we're going to start this off on the things what not to do, right? If you talk to anyone that's been doing this for a while, and I'm talking about the advisors and even the students, but here mostly I'm talking about advisors, they're going to tell you, we don't have all the answers when we start out. And it's just as scary for us sometimes as it is for you, because we're trying to basically try and stay ahead of some very intelligent students. And so we're trying to be there, and we don't have all the answers, but hopefully we can help you, connect you with people that do. That's one of the wonderful things about this workshop and the workshop that we have back in September, is that you're going to be able to network with all kinds of people who have experiences in all kinds of different levels for that. So the first question I have is, how many people here, this is your first time here? Raise your hand. Awesome. Congratulations, you've made it this far. This is a big deal. And I'm going to tell you up front that all the work that you are doing or getting ready to do is worth it. You're going to have a great time when it's, we could tell you story after story. If you get any of the advisors and chat with them, they can tell you all kinds of just phenomenal stories about the excitement that students get when you do this and something actually works. Even when it doesn't work, the trouble that they go through, and then they finally get it to work, you guys get crazy excited. Now, you need to pick the brains of all the people that are in here. The people that have done this before, the students, the advisors, they're more than happy to share anything. This is a collaboration over competition kind of organization, all right? When we show you these things, we're trying to help you get over the hump quickly. So don't do what we did, the bad things like that, skip them, bypass them, learn from us, from the mistakes that we and our students made, and or the other students that are in here, and skip those, and I promise you, you'll have a much more successful first year and much more enjoyable. We want the program to excel, right? Well, the only way that does that is we have to get people to stop making the same mistakes that we did when we first started. Now, I know lunch is coming. I'm going to try and go quickly. I'm an interactive kind of person. If you have a question, please raise your hand in the middle. You do not have to wait till the end. If I don't see you, just holler out and say, hey, Mr. C. All right, and we'll do that. Goes for advisors as well. Please ask. And I'm going to give the cameraman a lot of exercise because I'm a moving kind of person. You're welcome. Yeah, well, it keeps you awake. Mechanical diagrams and wiring schematics. Are they really needed? Short answer is, everybody says, yes. Yes, you don't even know that for certain, but you know the right answer. The right answer is absolutely they are. First story that I'm going to tell you is this, and the only one. When we started this in Kentucky, back in 2018, we started doing this, and I went and asked the principal, said, hey, can we build a solar car? She was like, sure. She didn't know me from anybody. She just hired me. And she thought the only experience they'd had was little CO2 dragsters. That's the only thing they did. So she thought we were going to be building little RC cars. We weren't building RC cars. And I drafted the engineering teacher. I was teaching computer science at the time. And I drafted the engineering teacher. Why? Because I needed his shop. And the tools that they talked about before, we only had, we didn't have a full set of sockets or wrenches. We had a few mismatched pieces, some woodworking tools. We had a benchtop drill press that basically you had to pull it down and push it back up because the spring was broken on it, and one grinder. That's all we had. So trust me when we tell you that you can do this with very limited tools. You can do this with very limited tools. Now, the one thing that we did not have was the guidance help. There was no one within 600 miles anywhere within the U.S. to give us this, so we were kind of feeling our way through. The thing that we messed up on the first year was this. We did not heed the one bit of instruction that was given on the website, which is have mechanical drawings. We got in there like most everyone does, and maybe some of you have started this way as well, where you've gotten in there and you're real excited to start building. You've sketched out on a piece of paper or something like that, the rough idea of what you want, and you just go in there and start cutting metal and welding it together, and you're starting on your frame and chassis. We did the same thing, and there is a kind of a tradition on first-year teams, you're going to overbuild your car. And kind of, if you're smart, you're going to do that anyway. Our overbuild of our car ended up being 1,246 pounds and cost about 3 times what it should have because we kept having to do something, finding out that didn't work, and then going in there with a Sawzall and chopping it off and throwing it away, and then there's all kinds of just piles of just scrap metal over here, and we're starting over constantly. By the time we were finished, because we had a philosophy of when in doubt, add it on, our car weighed 1,246 pounds. We jokingly refer to that thing as the minivan. And if anyone was there in 2019 when we came, it looked like a big white minivan that had this surfing Wildcat on the side of it. I'll tell you a story about we'll come back to the Wildcat in just a moment because there's an interesting story that goes to that. Dr. Marks loved our Wildcat so much that he actually created an award just for the graphics for that car that year and gave that to us. We were very excited. The car was overbuilt massively. The wheels were out of alignment, the shocks and suspension system were horrible, but it was a tank. It would not stop running. It ran poorly, but it would not stop running. And we ended up coming into the last day. Our entire goal was we had heard horror stories of people going down, teams going down, and not passing scrutineering. And if you don't know anything about scrutineering, they're going to talk to you about that later and how to pass it. Please pay attention to this. It is very common for teams to not pass scrutineering down there. And we're coming from Kentucky, and we're sitting there going, okay, we're the only team to ever do this. And already we're having people tell us from the school, from the district, from the state, all the way up to the governor's office saying high school students can't do this. Well, that just kind of made our students all the more stubborn and saying we're going to prove them wrong. But we also knew that if we did not succeed, that it would never happen again in our state. There was a lot on the shoulders of the students doing this. We did not do the mechanical wiring diagrams, and we were fortunate, very, very fortunate. I will tell you this, as a first-year team, your car may not be the greatest when you get there, but as a second-year team, the difference between your first car and your second car is going to be phenomenal. What you're going to learn through this process and at the race of actually testing and running your car is going to be tremendous. Just hang in there, it's going to be good, I promise. Someplace. Okay, hit it next. Next. All right, here's what happens when you don't use mechanical drawings from the first part. I've already talked to a little bit right here. By the way, this is the beginnings of a 1,246-pound car that you're seeing here. That's what you're seeing right there. You're constantly in a build-rebuild cycle. You're making mistakes. You're trying to figure it out as you go. And what we ended up doing, the way we ended up adding so much weight to the vehicle was we'd read the rule. That was the other thing. Oh, I'm going to back up here. Read the rules in advance. See, everybody that's laughing knows that this is read the rules in advance. I can't stress this. Know the rules like the back of your hand. If you're going to go get your driver's license, you know that little handbook left inside and out. Know the rules. It will save you tons of money, tons of time, and you'll have a better product. We did not. Okay, I'm just going to tell you, on that very first car, we did not. We would do something, come up with an idea, and when you read a book, read the rule and go, oh, wait, we can't do that because it's too big or too small or the wrong size or in the wrong place. So we kept adding things to the car. We'd read one rule, and we go and we put it on the car. We read the next rule, and we go and put it on the car. By the time we were finished, this thing was literally a tank. I can't tell you, this section right here, you see the shock? Nowhere near sufficient to hold up the entire car by the time we were finished. We literally had to put in a solid piece of 2-inch tubing, square tubing, in order to hold the back in the car. No shocks. All right.
No, the right. You're hitting laser.
Arrow?
Yeah, arrow.
No. All right, just bring them up on the screen. We'll go through like this. They're ready to get to lunch. Significant increases in frustration level for all. When you're sitting here putting things on the car and then all of a sudden having to go back and tell a student, no, that's not going to work, and you're going to have to cut it off, everyone gets frustrated because you've lost all that time and aggravation and the time and energy and money that you've put into that. And you understand, where this car was being built was not in a large city. So this is encouragement for those of you that come from smaller areas. We were in a rural area, a farming community. The biggest industry there was the high school. A high school of 540 students, that's it. So when I tell you that we weren't certain whether we were going to get this done, we just simply didn't have the industry and all the finances like a lot of the places do. So I'm just telling you, it can be done. But when you're sitting here cutting pieces off, that's money that's going away, that's time that's going away, that's energy that's going away. It's just very, very frustrating to you and everyone around. Loss of time and resources, many very late nights and mornings. When I say late nights and mornings, we were working till 2:30, 4:30, 6:30 in the morning, going home, taking a shower, and coming back at 8 o'clock in the morning to work all day long again. That's what they were doing the first year in order to get the car done. It's not necessary if you organize your stuff by having your mechanical drawings. Reduction in quality. The quality of this car, if I were to compare this car to any of the other cars that have come since then, this was garbage by comparison. But it was a tank, and it ran, etc. and so forth. Go on, next page. Mechanical drawings improve. They improve your design and assembly, cost savings and quality, safety, maintenance and compliance, communication and coordination, testing, design, optimization, supply chain management. Next. Design and assembly. Quality mechanical CAD drawings and wire diagrams provide accurate and detailed information about the design and the layout of the car's components, improves assembly efficiency and reduces the risk of errors and delays. I put it here, division of labor. One of the key things that this is going to do is, one, when you have your mechanical drawings that you have, from the time you start to the time you finish, are going to change. They're going to evolve as you go, as you realize, hey, we need to modify this right here when we get in there. Things are going to change on that. We understand that. They even understand that at the Solar Car Challenge. When you send your things in March, your package in, they know that some things are going to change from the time that you send your package in till the time you get there. So it's not that you have your drawings and say, okay, this is the car. It's going to change over the process. However, it allows you to break that into subcategories. Your electrical departments, high and low voltage systems, your suspension systems, your frame or your safety shell as they do that. You can have teams that are broken up into this. And you have to have your mechanical drawings in order for each of those teams to actually function with one another. Because if you're simply say, hey, go build me a frame, and you have another section say, hey, go do some suspension system for them, if you don't have a plan and something in place for this, that everybody's looking at the same blueprint, they're not going to match up. That's a guarantee. It's sketchy sometimes even with the blueprint because someone didn't read it properly. But you greatly increase the opportunity and the odds that you're going to have a quality product, and you can break this, do a division of labor here. Next. Having accurate and detailed mechanical CAD drawings and wiring diagrams can help reduce the cost of building a solar car by reducing the need for rework, assist in ensuring the car is built to the highest standards and quality of performance. We've already kind of beaten that horse solidly. Have them like there. It's going to greatly reduce the cost that it's going to do this. The cost of our first car was 3 times what our second car was, and the second car that we built was significantly better. I mean, I can't even tell you how much better it was. Go ahead, next. They can help ensure that the car is built safely by providing detailed information. The biggest thing here on safety is in your the rules for the Solar Car Challenge, understand that stuff there is to keep you safe. All right, they give you general guidelines for the build and how you decide to design your vehicle, but the other things in there telling you what size materials to use for your roll bar, the spacing for your crush zone, so forth and so on. All of that is there with the intent of trying to keep you safe out on as you're driving. If you don't follow that, you're going to either have issues with something not working right, or you may get here and not pass scrutineering because you didn't follow the rules for a critical area. You decided to have a roll bar that was 1.5 inches in diameter rather than 2 inches in diameter, or 5 centimeters, right? Well, I guess 2 inches. Makes it easier to maintain the car by providing detailed information about the location and operations of components. I'll talk more about that in just a moment when we get to the wiring. Compliancy. You need to your car needs to be compliant when you go to solar car. Now I will add this in, and they'll talk more about this later. If you are going to do something that is a variation on the rules, if you're going to modify them significantly, please contact the Solar Car Challenge and say, this is what we're proposing. They are more than happy to try and help you out in that regard, but they don't wait until you get to scrutineering in order to ask for a waiver for something or a variation on that. Ask in advance. By having your CAD drawings and your mechanical drawings and your wiring schematics and your wiring diagrams, you will see where you may need to ask for a waiver for something far in advance and give them plenty of time to give you feedback and then to modify your systems beforehand. Next, please. Serve as a common reference point for the team. The first thing that we do when we have our mechanical drawings accomplished, and I don't even let them start building until they have their mechanical drawings accomplished, is we print them out and we put them in several locations. They're in the classroom where we give lectures, and the computer systems are doing research for stuff, and they're put out by different divisions or sections of the vehicle. They are put in our electrical and electronics room, and they are put in the shop. Great big posters of them put out. Why? So that everyone knows where we are and that we're all on the same page. And if there's a single change made, they're all taken down, reprinted, and put back up so that everyone is on the same page. You want the people that are out there putting the frame together, putting it together in the manner that you expect if you're working on the electrical system back in the electrical room. And we don't run our electrical systems inside the mechanical room because we don't want those things to intertwine with one another while you're doing under fabrication. We want to keep them separate until we're ready to put them on the vehicle. By doing this, it allows you to keep them separate and to actually have your teams all on the same page. It also gives talking points to your people who are doing fundraising as well, which is a very important aspect. Every now and then you'll get a hold of people that just want general information about the car, but sometimes you'll get people that want to geek out about everything that you're doing, and they want to know the science, and they want to know the engineering that's behind it. And if you have these things and everyone's on the same page, then everyone's talking the same game. Next, please. Next, skip this. This right here, this is for your project managers. You're going to need project managers, ideally, if you're going to have somebody that's kind of monitoring the time, materials, and are making sure that everything's staying on schedule and staying on budget. In order for them to do that, having your mechanical drawings, knowing what materials you're going to need for building the frames, building the suspension, the electrical components, whatever the case may be, allows them to work with their project managers and to get these parts not when you need them, but before you need them, so that everything stays smooth and functioning. With your mechanical drawings, you basically spell out everything for that. In March, you're going to have to put that, send those in, including a list of all the materials that you're going to, that you plan on using on your vehicle. Your mechanical drawings are going to help you identify what you're going to need, things that you probably didn't even think of initially. On next, please. A few examples. These were the drawings that we did for at the last minute after the car was built the first time. And the car didn't end up looking anything like that. So these were actually horrible designs. These were the ones literally we sent in, and then we had to update them when we went in because the car didn't end up looking like that at all. Next.
Didn't you get the Siemens award for that?
Not for this year. The Siemens Award came the following year, and I'll show you what did get us the Siemens Award for that, actually for two years straight. This was the color aspect, and I will tell you this, when you do your mechanical drawings, I highly recommend that you color code the main portions of your mechanical drawings. Next, please. We'll go to the next. Before I get to the other ones, these right here, what we moved to was in the second year, after that first year, and we learned our lesson. This is the kind of, every piece that was on the car, these are not pieces that we downloaded. These are pieces that students actually CAD'd themselves. But these are the actual pieces on the car. Those are MCP calipers, master cylinder. Those are wheelwood calipers over there. This was the design for the rear end and its mount for the motor and stuff like that. They literally drew them out, and they're actually to scale or to size for that right there, and they then did assembly with that so that if anything changed on that, and I will recommend this, hint, hint, when you do your CADing, do not do it all in a single part. Break the car up into parts. All right, the more parts you have, the better off you are. Why? Can anybody tell me why you want to break them into parts? Why would you guess? Tell me. If you want to change something, it organizes, exactly. You can put all your suspension parts in a folder, and if you want to change a single item, you're not having to go all the way back and redo the entire thing. You simply do that one part, and it will update your assemblies. If you use Solid Edge like we use, then it will update that. So do your pieces separately. Now, they got a little overzealous on how detailed they made our parts. We bought our parts, and they literally got in there with micrometers, and we're actually measuring everything, and we're doing that. Now, it's handy to make sure everything fits. This may be a little more detailed than you actually need, but it might get you a Siemens award. All right, next. Next, please. All right, so this is what we move to next. I will mention in here the first thing, you'll notice that there's a guy sitting in the seat. You do need to have this in your drawings now. This was an option at this point. This was our second year car. This car was significantly different. This car would do, with the gearing ratio, it would run 44 miles an hour, and we did run that off the track. It was a rainy day one time. We were putting a rooster tail taller than I am with water coming off the back side of it. I would not recommend it. It's an efficiency test, but we were having fun that day. In here, the little drawing in there, if you use a program called Make Human, you can make the little model. He'll stand like this. Can't do anything with him, but then you can take him and put him in Blender, bend him down, and put him in the vehicle. We had, for every person that was going to be a driver, do you have another suggestion? If we do that, and we would measure out each of the drivers for that and get their exact measurements, and that way we know that we have the clearances that are required for that. So when we put them in, you'll notice that there is 2 black spaces. It shows the spacing between their head and the bottom of the roll bar. You're going to need those in your drawings now. Next slide, please. You'll notice that there's a 10-degree marking there for showing the distance. Make sure that they have the 10-degree requirement for the solar array. From their eyesight, there is a measurement. In one of them, they'll show from their eyes to the ground because there's a minimum requirement for eyes off the ground. You'll notice that there are dimensions everywhere in here. Next, please. Top view, again, all the measurements as well. And you'll notice here, this is the easiest one to see the coloring. I said I highly recommend coloring your graphics for this. In this one here, you'll notice that the red there, that represents the crush zone for the section for the material, so that when the judges are looking at this and reviewing it, they know exactly what you intend to be the crush zone portion. You'll see the orange, that's the roll bar for that. The gray is actually the frame for that. The blue is a separate piece. I don't know why they colored that there. Next. Next. Wiring diagrams and schematics. Trying to get you out of here. Ooh, 1212. First thing we need to know is what's the difference between a schematic and a wiring diagram. They kind of blend a little bit between the two. A lot of people have a tendency to interchange these two words, but they are slightly different. And I'm just going to give you the quick definitions. When you get the PowerPoints, yes, sir.
Well, I was going to say, you might say that people will come to your workshop tonight at 7:15 because that's what you're talking about, how to make a good schematic.
Oh yeah, what is that, 7:30 or something? 7:15. So if you need a precursor to going to bed tonight, 7:15, you can come to that right there, and I'll get you nice and relaxed and drowsy beforehand. But we're going to cover the wiring diagrams this evening. A schematic is a more abstract representation of an electrical system. It represents an electrical circuit components and their respective connections in an easy-to-read visual format. A schematic does not contain details about the wires, physical location, or its measurements. That's a key component. The schematics are more generalized and they are very specific. Next, please. This right here is, on the left-hand side, you'll see that is a sample of a wiring schematic. It is not a car schematic. Don't look into it and say, oh, that's a solar car schematic. It is not. And it's very complicated in this one. They don't have to be this complicated, first off. And on the right-hand side are samples or examples of different types of some schematic symbols that you might use. Does not mean this because they're on here that these are the ones you're going to be using. I just put them up there to give you an idea of what it may look like. What we typically use more is the wiring diagram. A wiring diagram is a visual representation of the physical connections of the wires in a system. It's helpful to troubleshoot and understand the overall structure. It provides a detailed description of how one wire interacts with another and which components are connected to each other. It usually includes detailed illustrations that display how each component interacts with the other elements. Next. This is what I'm referring to when I'm referring to a wiring diagram. It's kind of you can mix the two, blend them two like that. You could put some of the schematic symbols in here in various locations, but it's not actually required. They do want you to provide in your, one of the new things is they want you to have both a schematic and a wiring diagram. The schematic is for those electrical and doing the electrical engineering, look at it, they can look at it and make sure that the wiring is appropriately sized, that your components, your relays and contactors and refuses like that are all, it's an easy thing for them to look at and make sure that everything kind of makes sense for this. This is for us. This is the drawing that helped us win, as Dr. Marks says, the drawing where you saw the make human person in, and this is kind of what we did, helped us to win that award. And I'm going to tell you the story. I told you I had a story about the graphics person. You know, we had that little surfing wildcat on the system. The young lady on your team, they mentioned earlier that you're going to need all kinds of different people on your team. Everyone initially thinks that solar car, I don't know anything about building cars. Well, you don't need just people building cars. You need fundraising individuals, you need project managers, you need graphic arts, you need finance people, you need all kinds of different individuals with different skills on there. The young lady that did the graphic on the side of the car, her and her sister, did that and did the wrap on the car, all the finished pretty of the car, and was in front of the camera. They were the ones that did all of the public speaking for the team, because let's face it, some of our egghead electrical and mechanical guys really should not be in front of a camera. Right? They get in and go, kind of thing, right? So what happened was, though, we heeded the suggestions of the people before us after that first year that said, hey, you need a notebook when you go to scrutineering of everything in there and take it with you. Well, we said, okay, if that's the case, what we need is we need to put this out so that if you don't know anything about this section, it'll be good. Lo and behold, this young lady wasn't supposed to, but she went along with the group to the electrical station at the scrutineering. She had never touched the car. The only thing she had ever done was wrap the outside of it. The inside and mechanical aspects like that was not her job. And she's standing there just wanting to see so that she could talk about it in front of the radio. And the electrical lead judge there said, okay, so this switch turns on X. Will you, and he pointed to her and said, will you trace it on the car? She had never touched it. However, we had our handy-dandy notebook, and our handy-dandy notebook had this graphic in it. In addition, on the car, these are not randomly drawn wires. We had tubing down the side, and every one of those wires are appropriately colored for the colors that were actually on the car, and they went that direction on the car. Where these things are located in this drawing is exactly where they were located on the car. So what she did, because it was exposed, she opened up the notebook and followed the notebook and the car and traced it through the car for her by using the notebook that we had given her. So she didn't know how it was put together, but it was in a manner that she could do this for us. Now, what we've learned is, don't send your video people to electrical next time. But I tell you that because here's what's going to happen. Even if you send the right people to the different stations, mechanical and electrical, you're going to get flustered. The first time you go, you get nervous, right? I will tell you this. Hint, hint. Who is the expert on your car? Who's the expert on your car? You. You are the expert on your car, right? You know how you designed your car and why you made the decisions that you did. The judges are here to make sure everything is safe and to make sure that you built the car. Prove it to them. All right? Don't be afraid to tell them, say, no, this is why we did this. It's okay. They don't have to agree with it. As long as it's safe, they're going to let you go. All right? They may have done it differently. That's them. Next page, please. This is okay, go back to the first one first. The first one seemed overwhelming to everybody, and that's the reason being is because we were just in our second year here, and we still had far too much wiring on the car. We overcomplicated the electrical system for it. It did not need to be this complicated. Go to the next slide, please. That is the actual wiring for a four-seater that we're in the process of building. You notice how simple the wiring is on it? Keep your wiring system and your electrical system simple. Don't overcomplicate it if it's not necessary. All the things that were in the other one are here, but just in a much simpler system. Next. High voltage. This is our high voltage system. You'll notice, if you can remember back to the first picture, all of the wiring was on which side of the car? The top or the left, right? Where's all that was all low voltage. This is all high voltage. Where's it? Right. I'm not saying you have to do this or you need to do this. This was our philosophy on this right here, is that our driver was going to be on a track, going to be getting out on the left-hand side. We wanted all our low voltage on the left-hand side, so there was no possibility of our driver inadvertently catching a high voltage wire for that. In addition, we didn't have any high voltage systems. You'll notice there's no high voltage wires inside the driver compartment. We put them all on the outside, and they come back here along the back side and on the right-hand side. Now, you may choose to do that differently, or they may overlap. It all depends on your particular car. You are the expert on your car. This is what we chose, yes.
There is a rule that prevents high voltage from being in the driver's compartment, so it is required.
Yes, that part. But I mean, as far as where you put them left or right. Correct. So that's what we did. This is the high voltage for this. Next. That is the high voltage for the other system as well. Next. Questions, concerns, comments? Yes, sir.
A couple of questions for you, Brian.
Shoot.
So, number one, you talked about it's better to make the electrical system more simplistic and complicated. Is it possible to do that without having an electrical diagram or schematic?
No. No, it is not.
And can you ballpark how many wires are in the solar car? How many wires?
Okay, let's see.
It's quick.
Hundreds, thousands.
Yeah, it's okay. So I'll say this: there was our first year there, our second year there. There was a car that was beside us. It was a first-year team, and I kid you not when I say that the wiring. I'm not even going to call it a harness because it didn't even come close to that. It was a complete rat's nest. Everybody know what I mean? Everybody's seen a rat's nest before? Like literally it's just a bunch of stuff scrambled. That's literally what it was. And I'm going to take a little bit of somebody's thunder here. Don't come to scrutineering with your car not built. All right, and that was the issue. This team was still trying to finish their car, including their electrical system, and they're literally... depending upon how your car is set up and its telemetry and everything like that, there are countless number of wires running all over the place. Organization is key. Here's the one thing. The first year, we had one major issue on our car. We had issues as far as the car not running efficiently, but as far as getting through scrutineering, we had one major issue that we ran into, and this is a common problem on vehicles, I believe, is that we had a floating ground on our car. So you are not allowed your car, unlike a traditional car where you may ground to the chassis of the car. We can't do that in solar car because we're dealing with high voltage and there's a lot of risk there. But so they will actually put a meter to the frame of the car and check for current, right? Well, had a floating ground on ours that was just above the minimum allowance for that. It's very, very small. What we didn't realize was, and I'll tell you this, hint, hint, in case you're doing the same thing. And I've heard a couple other teams, I think even Iron Lions may have had this issue one time, and when they first started. Our turn signal system mounted to the steering column on the car. And it was in a plastic housing, but it used a pipe band for it, the little adjustable pipe bands for that. And we wrapped that around. Well, the column on our steering, that we had around our steering shaft was actually metal. So when we put that around, even though everything else was insulated, somehow or another, there was a slight current between that metal band getting to that, and it was floating throughout the entire car. This is the second car. So the second car, we had the drawings that you saw. So when we had a problem, we were checking floating ground. We were doing tests on every one of the wire runs, which didn't take us too long. It took us probably about an hour to get through all the wires to actually test them. All right, which may seem like a lot to you, but when you're literally going through that many as many wires are potentially on a car, that's actually not that long. And we could not find it; they were all fine. And then we just happened to look down as they were crawling down underneath the dash, saw that band under touching the metal, and we got up there and took the housing off and tested it, and sure enough, that's where it was. And all we ended up having to do was put some insulation, some rubber insulation around the shaft and put it back on, and everything was golden. But had we not had the mechanical drawings and the wiring diagrams, we may never have found that, which would have been a DQ, a disqualifying event for the race.
Right. I will tell you more going with that. With a couple hundred wires in your solar car, if you don't have them identified, you don't have them tagged, you don't have them organized, I've seen multiple teams not just lose hours could actually lose multiple days of racing time and taking themselves essentially out of the event for some small electrical issue that's in there. And had they been more organized, spent the time with it, they would have actually been able to compete. So this is a big deal from somebody who's been doing this for nearly 30 years now. The schematics are important. Don't treat them like an afterthought, because you will have problems, and they will be the biggest thing that will help you when you have a problem. And also be organized, because also if I see a rat's nest, I won't let you guys through scrutiny. I will make you go and tidy it up before I do the final sign off. So yeah, it's important.
Last thing I'll mention on that, unless there's a question, is this. The one thing that we decided to do between those times was we run all of our wiring, but then we run it all through conduit. And there's two different types of conduits that you can do. You can have a solid tube, or you can have a split corrugated tubing that you run through. We run everything through conduit to make sure that, to reduce the odds that there's any chance of a wire or something metal within the electrical system coming in contact with the frame, to reduce that, because we simply don't want, if we're going to take an hour, we want to spend it on something that's productive in making the car, checking that air pressure or something like that makes the car run more efficiently, not on fixing something that we could have prevented in advance. Prevention, there's a thing with the 5 P's of success. Proper planning prevents poor performance. If you plan accordingly in front and get ahead of it, then your success is going to be much greater. Any questions?
Why don't we hold questions for you to come up and talk with them individually, and let's break for lunch. And we'll see you after lunch for preliminary, but let's give Brian Coleman a round.